Assalamualaikum. My name is AISYATUL AMIRA binti AZLAN. I'm from class 2 BEEY, section 1/1. My matric number is B0819100060. I want to share about my simulation on lab 5 about motor speed for part 1. This from the lab that we can see here, this lab is almost same from the previous lab that we have done, but in this lab we just add a gain block at the in front of real system transfer function block as a proportional controller. So to get a different output, we just need to change the value of the gain block, and we use 3 different value. First 0.5, second 3, and the last one is 5. So we construct the circuit to the MATLAB. This first we change the gain block value for the gain block. First we change 0.5. 0.5 and then apply. Okay. Second, we change the value for the step in the Lect sheet. Step time 0, initial time 0, final value 1, and sampling time 0.001. Okay, and then we change the value for clock. Dismission 10, then okay. And the last one is stop time 1 second. Stop time 1 second. And then we have to save the simulation as L5K1. So we save as L5K1, and then we run. After we run, we go to the command window. First, we type T equal to data, enter, K1 because we use K1 equal to out.out1.data, save T, we save K1, and then we plot the graph for T and K1. Enter. And then we got the graph like this. This is the graph for 0.5, and then this is graph for 3, and this is graph for 5. Okay, first from the graph we have to label all this. First we label TP and TP1. TP is peak time. That time is required to achieve the maximum overshoot peak based on the first oscillation, this oscillation. So TP1 for real 1 and TP for the graph real. Second, we label for TS. TS means cycling time, the time required to achieve steady state value. So for TS, we use two formula. First, 1.02 multiply with the final value, and the second formula is 0.98 multiply with the final value. So we insert line and then we this until the line touch with the any graph. So when it touch, then we get the line and then we label for TS. So this is TS for graph 3. TS for real is 0.067 second. TS for real 1 is 0.073. The second, the third and the last, we have to label TR. TR means rise time. The time for the waveform to go from 0.1 to 0.9 of its final value. So formula for 0.1, 0.1 means 10% from the final value. 0.1 multiply with the final value, and the second 0.9, that means 19% from the final value. The formula is 0.9 multiply with the final value, then we get the answer. Then we insert line until it touch the first oscillation graph, and then we label as TR. TR means TR for real, TR1 for graph real 1. So you can see this is the value that I have get from the graph. The final value for 0.5, 3 and 5. Peak value means the maximum overshoot peak value for the three graphs, 0.5, 3 and 5. TR, TS, TP, percent of OS, ESS. This is all the value that I have get. So this is the graph that I have labeled 0.5, graph for 3, motor speed, and 5. So the task that I have to answer here for question A, from your observation, what is the difference between data with and without proportional gain? So in my opinion, this graph, the yellow one, is the graph with proportional gain, and the red one is the graph without proportional gain. So I can conclude here is with proportional gain, we can see that the graph is more higher than the graph without proportional gain. Question B, how significant result obtained using different proportional gain value? We can see from the graph also, the highest proportional gain, we can get higher speed control system response. So this is the graph for 3, and the peak is 1.551, and for 5 we get the peak for with proportional gain is 1.633. So the last answer is analyze the system performance for 3 different proportional gain in terms of time response analysis. So we can see here, this is the graph for 5 motor speed with 5 proportional controller. In terms of time response analysis, when the highest value of the for the highest value of the gain, the time for the speed is short. The graph we get from the graph. So this is 5. So the time is very short with the graph for 3 and also for 0.5. But in all the graph that we have get, they achieve steady state at 0.1 second and above. So this is the steady state when the graph is achieve the maximum steady state. For 5, for 3 also 1.0 second and above, also 0.5. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya AHMAD AL-HADRAMI bin RODIN JAYA. Nama majlis saya B0819100056. Dalam lab 5 subjek Control System Fundamental, Speed Motor Design and Time Response Analysis, saya telah buat bahagian part B, part 2. Ini adalah circuit yang telah saya bina daripada mengikut kepada lab sheet yang telah dibagi. So ini adalah filter, ini adalah real 1, real. So filter ni ni yang dah yang ketiga. So saya dah siap run semua. So lepas saya dah run, saya akan pergi kat command window, saya type untuk yang pertama, additional pole yang pertama, saya akan gunakan sebagai T1 dan P1. So saya dah siap rekod. So daripada tu saya telah dapat 3 graf yang berbeza. Okay, di sini ni adalah graf yang pertama yang menunjukkan additional pole yang pertama. So graf ni saya dapat kena pasti dia punya VP iaitu VP 1.82653 dan TR dia adalah 0.067. Manakala untuk graf kedua yang telah saya plot, ini adalah untuk additional pole yang kedua. Saya dapat kena pasti TR iaitu 0.2049 tolak dengan 0.028. Saya dapat nilai dia 0.1769. Untuk TS dia adalah 0.085, VP 0.29, TP 0.187 dan final value dia adalah 0.286. Manakala untuk plotting graf yang ketiga, iaitu untuk additional pole yang ketiga, dia punya TR saya dah dapat 1.5.26 tolak dengan 0.129. Jawapan dia untuk TR dia adalah 1.397. Manakala untuk TSG adalah 2.571. BP 0.953, TP 3.957 dan final value dia adalah 0.9527. Ini adalah table yang siap saya isi. Untuk nilai peratusan overshot dia, untuk part 1, pole 1 tak ada. Pole 2 1.399%, pole 3 0.031%. Manakala nilai ESS untuk pole 1 juga tak ada. Nilai pole 2 juga nilai pole 2 adalah 0.714. Dan manakala nilai pole 3 0.047. Daripada part 2, task yang diberikan adalah from your observation, what is the difference between result with and without additional pole? explain to your instructor. Okay, the type of graph will give distinct scenario. For example, for case 1, for the underdamped instance become underdamped instance due to the added pole to the graph. And B, how the additional pole affect your system performance. Explain to your instructor. Yang the pole of a transfer function are the value of the Laplace transform variable, so that cause the transfer function to become infinite or underdamped or overdamped. Any root of the denominator of the transfer function that are common to roots of the numerator. C. Identify system type for each additional pole. System 1 is a underdamped system. In a underdamped system, the poles are purely imaginary. Therefore, the system is marginally stable and the step response oscillated indefinitely. Manakala for system 2, it is a critically damped case. Loop that respond quickly are called critically damped loop. An example of the type of response would be a steam heating coil for a jacket type product heater. The jacket allows steam to circulate around a kettle and heat the product without touching it. Anytime the steam valve is open or closed slightly, the temperature will change quickly. And for system 3 is a overdamped system. The overdamped system response is a very slow response that used when bringing system up to temperature. For an example, when a process cooker is first brought up to heat, it will be heated slowly so that it does not crack. The heat from the cooker comes from steam. The steam wave is controlled with an overdamped response, so it opens slowly and allows the temperature to increase slowly. It may take over an hour to bring the temperature from room temperature to 200 Fahrenheit. And then show the plotting data for each input to your instructor. Okay. Okay, that's all from Lee. Thank you.